Usually you have done problem with pulleys having no mass. That means the pulley is ideal. But sometimes there are some numerical where pulleys may have mass. Like this year in JEE, one question was given where the pulley has mass. So how to solve the problems where the pulleys have mass? Let us try to discuss that. So I'll draw a pulley which has mass, and here is a string, an ideal string, and here is a block of mass capital M, and there is another block of mass small m. For this discussion, we'll assume that capital M is more than small m. So capital M will descend and the small m will ascend. Now what we'll do is that we'll draw the free body diagram. So we'll cut the string. So here will be tension T, and here also will be tension T in ideal condition. So in ideal condition, what happens? See, the tension that you are seeing throughout the string will remain same, because the concept is that as long as you do not face mass, the tension throughout the string remains constant. But if you see this diagram is true for the pulley which is ideal. But what we are discussing here? We are discussing here a pulley which is not ideal. That means the pulley has got mass. So the tension on the left side of the pulley and the tension on the right side of the pulley will not be same. So I'll take the tension on the left side as T1 and the right side T2. So remember that whenever there is mass of the pulley, the tensions will change. Okay. Now you go for free body diagram. So a block of mass capital M will have weight mg. Block of mass small m will have weight mg. Now if you use the constraint equation here, that means this length is y1, the length of the string on the left hand side, and the right hand side also let us assume the length being y2. As the string is ideal, so the length y1 plus y2 and part of the string will be obviously here attached to the pulley. The total summation will remain constant. That means if I take the double derivative of this total length of the string, what I'll get is that the acceleration on the left hand side and the acceleration on the right hand side, this magnitude will be same. Our target is to calculate this acceleration. How to solve that? Let me erase this. So let's go for the equation. So here you are getting the equation as capital Mg minus T1 is equal to capital M into acceleration A, and for the block of mass T2 you are getting the equation as T2 minus small mg is equal to small m into A. So this is equation 1 and this is equation 2. Now see, because this pulley has mass, so if a pulley has got mass and it is completely filled, there is no hole there, there is no orifice there in that pulley. So this pulley is as good as a disc. So I'll take this pulley as a disc. But for the time being, we know that the moment of inertia of the disc about its center is mr square by 2, but we'll assume that value as capital I. So what is capital I? Capital I is the moment of inertia of this pulley about its center of mass. Now what is the torque provided by T1 about the center? Let me call the center as O. It's going to be T1 into R. And if you use the right hand thumb rule, put the wrist at O and you curl it, and you can see that the torque of T1 is anti-clockwise. And the torque of T2, again put the wrist at O, do the right hand thumb rule, you can see the torque is coming as T2R and it is clockwise. So because this block is descending downward on the left hand side, that means capital M is heavier. So this means the pulley must rotate in what direction? It must rotate in anti-clockwise direction. So this means T1R should be more than T2R. So this is the unbalanced torque. And unbalanced torque is equal to what? Unbalanced torque is equal to I alpha. So T1 minus T2 is equal to I alpha by R. Now what is alpha? So alpha here is A is equal to R alpha, where A is this acceleration, right? Now how to get that T1 minus T2? To get T1 minus T2, what we'll do is that we'll add equation 1 and equation 2. So if we add them, we are getting capital M minus small m into G plus T2 minus T1, you can see here plus T2 minus T1 is equal to capital M plus small m into acceleration A. So what is the value of T1 minus T2? So if I do the side change of this, so I get capital M minus small m into G minus capital M plus small m into A is equal to T1 minus T2. But what is T1 minus T2? It is I alpha by R. So we can put from this equation, from equation 3, we get I alpha by R. But A is equal to R alpha. That means alpha is equal to how much? Alpha is equal to A by R. So put the value of alpha is equal to A by R here. So we get I A divided by R square. So this is your capital M minus small m into G minus capital M plus small m into A. Target is what? Target is to calculate A. So we'll do the side change and we get capital M minus small m into G is equal to, take A out and we get capital M plus small m plus I by R square, where I is the moment of inertia of that disc or the pulley. So A formula is coming as capital M minus small m into G whole divided by capital M plus small m plus I by R square. Now I'm not asking you to memorize this formula, which you can obviously, but it is better to understand this it is better to understand the concept here. So please check. I hope that this equation is clear. Now what is the question? So this is the theory basically. So what is the question that JEE has asked? So JEE has asked this question. So instead of that being a disc, they are saying the pulley is a ring of mass m and radius r. And now there are two rods. So one is a rod of length 2r. You can see easily that this is a diameter. So length of the rod is 2r. The mass of the rod is small m. And there is another rod which passes to the center of mass of the ring. And it has also got the same mass and same radius. So like this two mass, that means two rods are there having the same mass small m and the length 2r, and there is a ring of mass capital M and radius r. And now this center, this line, that point where the two rods intersect, it is fixed to this string. It's fixed to a string, and there are two blocks hanging. On the left hand side, the block hanging has got mass capital M, and on the right hand side, the block hanging has got mass small m. Now we need to find out the acceleration. So if you use this formula that we discussed few minutes back, we'll get ready-made answer. But I'm assuming that during exam you don't remember the formula. So, and usually this kind of question is also not asked. So you won't be ready for this kind of problem because that formula is not in your mind. So how to solve this directly? So what we'll do is that as soon as the pulley has got mass m, so we know now that on the left hand side and on the right hand side, the tension are not going to be same. So we'll cut the string first. So string is cut. Here the tension will be how much? T1. Here it is T2. Here it is capital Mg. Here it is small mg. Using the constant equation, both the blocks will have the same acceleration, and the question is asking us to find this acceleration. Here it is T1 and here it is T2. So I am assuming that the free body diagram that I have drawn is crystal clear. So the first equation for the block of mass capital M, it is capital Mg minus T1 is equal to capital Ma, because capital M block is descending downward. And for the block of mass small m, the equation is going to be T2 minus Mg is equal to small ma, because that block is ascending upward. So this is your equation 1 and this is your equation 2. Right? Now for the ring with the two rods. So what is the unbalanced torque? T1 into radius r minus T2 into radius r. Now why T1 is more than T2? Because the capital M is more than small m. So this block of mass capital M will descend downward. That means the pulley or the ring is going to rotate in anti-clockwise direction. So anti-clockwise torque has to be more than clockwise torque. Now this equal to I alpha. So let us try to find out the moment of inertia of the ring with the two rods. Now what is the moment of inertia of a ring about its center of mass? Its value is capital M r square. What is the moment of inertia of the rod about its center of mass? The formula is ml square by 12. Now what is the length of the rod given? It is 2r. So the moment of inertia of each rod is m 2r whole square divided by 12. This is the moment of inertia of one rod. But like this, how many rods are there? Two rods. So multiply this equation with 2, and moment of inertia is scalar quantity. So you add them to get the total moment of inertia. So what answer I am coming? M r square plus here it is m r square by 3, and there is a 2 multiplied. So 2 m r square by 3. So this is the moment of inertia. So T1 minus T2 taken radius out, I value put capital M plus 2 small m by 3 into r square into alpha. R and R cancel out. So this is your R alpha, and the R alpha is the tangential acceleration, and this is a formula from circular motion. So what we can do here is that capital M plus 2 small m divided by 3 is equal to A, where A is tangential acceleration. Now our task is to get this left hand side. So our task is now to get T1 minus T2. How to get that T1 minus T2? So to get T1 minus T2, we'll use equation 1 and equation 2. This means this equation and this equation. So if we add them, you can easily see, if we add what we are getting capital M minus small m into G minus T1 plus T2 is equal to capital M plus small m into A. But our target is what? Our target is to get T1 minus T2, and we have got here what? Minus T1 plus T2. So we'll do the side change. So if we do the side change, what we get? Capital M minus small m into G minus capital M plus small m into A is equal to T1 minus T2. Now put this value of T1 minus T2, which is the left hand side of this equation, in here, in this. So what I am going to get? I am going to get capital M minus small m into G minus capital M plus small m into A is equal to capital M plus 2 small m by 3 into small a. I'll do this side change. So if I take this on the right hand side, I get capital M minus small m into G, A out. So there are two capital M, so this becomes 2 capital M plus, if I do the side change here, I get 5 small m by 3 A. So simplification will give me the answer of A as 3 into capital M minus small m into G whole divided by 6 capital M plus 5 small m. This is the final answer of the question that is asked in this year's JEE. So please go through the solution. I'm assuming that you have understood it. Hope you have liked the video. Please don't forget to like and subscribe to my channel. I will bring more such PYQ questions in the next video. Thank you for watching. Tata. See you in the next video.